Hello everyone, this is an experiment that we've been working on for a while and just giving you an update video. What the project is well, first of all, this is a tea kettle. So I wanted to take something pre-existing that was made for heat, made for, to handle high heat. And this system here, we put in 3 fuel injectors here. We mounted 3 fuel injectors into the tea kettle and ran wires which will plug into the stock wires
that go to the car injectors.
That go to the car's stock fuel injectors. So the stock fuel injectors would be unplugged, and we plug these in. And if that didn't work, we would make our own system to run this fuel injectors manually. So we have this is our fuel rail that delivers fuel to the to these injectors, and this is a return line. So we kind of just set it up so that it's similar to the way a car usually would work, with having fuel delivery and then fuel return. We just have this hooked together for now. That's just temporary. That's not the way it goes. So we have this would go to the fuel
The rails, the fuel pump.
Fuel pump, and then this
yeah, return line.
Return line. So one's going to the fuel pump and one's going to the return line. And let's talk about also why we're doing this.
This creates a vapor. This is a hot plate that the kettle sits on, because we have to get the kettle up to 700 degrees in order to create vapor.
Yeah.
The injectors inject into here, and the gas creates vapor.
Yes, and we realize that gasoline does vaporize at ambient temperature, but if you go to YouTube screen name, I am Billy the Kid, or Bill Kendricks, same person, on YouTube, he found that when you bring stainless steel or steel up to 700 degrees, that you can actually convert all of the additives and all of the gasoline into a vapor. And he also found that he was, with a dyno test, that he was achieving an increase in horsepower. Bill said that he actually achieved a doubling of horsepower, so I'm not going to know for myself until I actually do my own testing on that. So I would say that the interest that we have is in increasing horsepower of the engine through allowing more air to mix with the fuel in the combustion chamber. That's the idea.
Well, you're burning, normally you're only burning 25% of energy to use your car. This we're hope to achieve 80% or better.
Yeah, that's right. Yeah, that's right.
And the reason 700 degrees also, it vaporizes faster. Below that, it does vaporize, but not very fast.
Yeah, some of it will, but not all of it.
And so that means, and that way you're more efficient. You're using all of 100% of the fuel.
Yes. So we're going to see if we can get more power from the engine. A really big thing, I would say number one, is to see what emissions do, the exhaust emissions. We were very interested in what the exhaust emissions do, because we know that the catalytic converter, which is in the exhaust system of all newer model automobiles, burns up the unburnt fuel. And we also know that carbon monoxide, which comes from cars, is from incomplete combustion. And if you read up on physics and engineering of the internal combustion engine, you'll see that it's no secret that engines only they burn partial combustion. They call it partial combustion, not complete combustion, when you run gasoline. So we're trying to see if we can run it closer to complete combustion or complete combustion, which would mean, theoretically, I think, from what I've read and researched, the true stoichiometric burn, complete, balanced, equal burn of the gasoline inside the engine, would mean there would be no hydrocarbons, no carbon monoxide, and just the things that we test when we do a smog test. Those should be zeros. But we'll see. We're not going to know till we try it. But this is the things that interest us. I don't know what the miles per gallon will be, but if there's an increase in power and there's a decrease in exhaust emissions, I would be very happy with that, even if the gas mileage didn't change at all. So I wouldn't say gas mileage is the goal, if I call it that. I would say the interest, which is a better word to use, is in seeing what exhaust emissions do and what the power does. Now I realize it's going to take power to run the heating element. This is a 600 watt heating element, and but I was reading on how people have converted their vehicles to be they put a really heavy duty alternator on them. A lot of people that have like car stereo systems, really big ones that compete in competitions, they put more powerful alternators on their vehicles. They have like 100 amp alternators and 200 amp alternaters. Also, people have converted their cars. I've seen some that have done welders. Okay. Oh, well, just talk here. Talk. Go ahead.
What part of the purpose is we need to do is our next design. A little bit better design than just a teapot. We were first starting in this, and that's what the video is about too, is to show that this is a starting design. Our next design, we're going to have to go to a machine shop, have a better delivery fuel, vapor chamber made, and then like he was talking about our power supply on powering our heating plate, on how we're going to do it with the bigger alternator and maybe bigger batteries, but that's our next step and our next design in our project. And we're just kind of showing what's happening, what we're doing now.
Yeah, just giving you guys different angles here. Let's go look at the truck that we're going to try starting. We're going to try to show you guys how a V8 engine can run on the vapors. We have the hot plate warming up here. This is just plugged into the wall right now. So the hot plate is up to 900. Okay, it varies. Looks like we're around 830. So the gasoline will not light until it reaches the temperature of approximately 950 to 1,000 degrees. So yeah, we want to just stay above 700 to get complete vaporization, but below 950. So we're going to do that, and we're going to try running this. This is what we've done. We pulled off these here, this tube, the stock air inlet that went from here over to here, and we just put this tube here, and we're going to have this tube, which is just a vacuum cleaner tube. We're going to have that going to
into the teapot.
The teapot. So we're going to do that next. I'm going to cut right now, and then we'll see if we could run the engine on vapors produced. Yeah, we have in the past. We're going to see if we can do it again for you guys on camera here. So see you soon. Bye. Okay.
No, we ran out of gas.
Oh, we ran out of gas in the. Okay, we ran out of gas in our spray bottle, our chemical spray bottle, and that's a vapor. Pull it out. That's our gas vapor right there. Can't really see it. We use the spray bottle because.
Light. See if you can see the vapor still. It's still vapor.
Yeah.
That's our vapor coming out.
And let's show the temperature. Can you lift the kettle with your gloves on? So you see our temperature is over 800 degrees, and the gasoline did not auto-ignite.
Over that it will.
Yeah, over that it will auto-ignite. And that was a V8 engine running that you saw. Here you go. This is a V8. What year is this engine?
89.
This is an 89. 89 what?
5.8 V8 engine.
5.8 liter V8 engine. And as you saw, it was running well with the vapors.
We had the fuel injection disconnected, the pump, so it's getting no gas.
Yeah, we disconnected the fuel pump system, and we put this here to help hold the idle up higher.
Yeah, kept the butterfly open so it'll help suck the vapor in.